Hey everyone, welcome to the Stellar Protocol discussion for May 12th, 2022. In these meetings, we discuss and plan for upcoming changes to versions of the Stellar Protocol, changes that are necessary to evolve the protocol to meet ecosystem needs. Just real quick, a word on venue. Last week we tried having this discussion in the Stellar Developer Discord, and there were some technical issues. So we're back to live streaming this on YouTube. We just don't want to let the technical issues of a platform prevent us from having these discussions so that we can talk about the substance and keep moving forward. We may experiment with other venues in the future, but we'll make sure to stress test platforms so there's just not technical glitches that prevent the conversation from happening. That said, we are discussing this week some caps that are related to Project Jump Cannon, which is an announcement that we made earlier this year that we are working to bring smart contracts to Stellar. And as part of that, there are protocol changes that need to happen. It's been a bit different this time because we've sort of modularized those changes into a series of core advancement proposals, each of which focuses on a specific aspect or a specific type of change that needs to happen to accommodate smart contracts. Now, if you're watching this right now, it's a technical discussion, so I advise looking at the links in the show notes, which are the actual links to the core advancement proposals that we're going to discuss, and to the discussions that exist on the Stellar Dev mailing list, which is where sort of long form question and answers happen. In addition to the Stellar Dev mailing list, there's also the Stellar Dev Discord, and there's a Jump Cannon and a Jump Cannon Dev channel in there. And anyone can join either of those forums in order to see the discussion unfold or participate in the discussion. We're doing this in the open so that you can sort of see the work happening, and also so that you can have a voice in the changes as we make them. So that said, there are a number of caps that are on the table right now that relate to smart contracts and to Jump Cannon. And we discussed a few of them last week. I think this week we're going to start out by talking about some of the classic smart interoperability questions that remain, most of which have to do with Cap 48 and Cap 49 that are kind of two different flavors of how to approach that. And as recent as this morning, there was some interesting discussion on the mailing list about that. And so I think we start there. And I think, I don't know, John, do you want to start?
Honestly, I'd rather just let Nico start. I mean, Nico posted this huge thing with a bunch of questions and I responded to it. So it's kind of Nico's turn to talk in the sense that I'm the most recent speaker on the thread. So maybe we can just kind of go through and we can try to figure out, basically just kind of talk through some of Nico's questions and understand what we're actually talking about and make sure we're on the same page on a variety of different things. And if we're not on the same page, get on the same page.
That sounds good. Wall of text, yeah. Sorry. Yeah, so I guess maybe, I don't know, one of the things we can talk about is actually around compliance, because I think that's actually the most important bit that is in there. I think we should discuss potentially changing, maybe not this time around, but that this is there's a level of expectation in terms of on the compliance front that I think we should maybe adjust even in classic so that we can make things work for Jump Cannon. So the type of things I'm talking about here is that both proposals kind of suffer from the same problem. So today, if you have an asset that you issued on the Stellar network, and you, our version, basically, we only have a couple of smart contracts basically on today, right? We have AMMs and the DEX. Those are the kind of equivalent. And today we track, if you have money or any asset locked into a contract, it's going to be recovered basically when your authorization gets revoked. And I think this breaks completely in Jump Cannon because, well, that's actually not, well, if we don't do anything, right? Because the only thing that gets really revoked is your trust line, the equivalent of your trust line. You lose access to your wallet, but if you parked your money in some smart contract that is the like the I don't know, shady guy on the corner, basically, there's no way to enforce anything there. So then the question is like, well, what do we do? Because if you don't do anything, in both proposals, we're basically saying, well, if you want to get around any kind of restrictions, just send your money to this smart contract over there, and then it's like this super mixer or something, and then like you can't reasonably have enforcement. So maybe we can start with that. Like we can say, well, that's okay, that's the new reality. And then then I would argue that we should just stop doing what we are doing in Classic, like, or at least say that we are going to stop doing, recover basically like assets from pools or from or the DEX, like if because that's actually a lot of the overhead that we have today in Classic. So I'll start with that. Like I don't know what people think.
So I can just start with saying how I responded to your question, to the same question from the email thread, which was basically like, this does work in Cap 48 and Cap 49. You just might not like the way it works. But like all the compliance controls that exist on Classic still exist. They just don't extend to all the contracts by default. So you might recall, Nico would definitely recall, because we spoke about it a lot, when we were doing the liquidity pools, that we had this discussion about whether we should go back and make people, revoke authorization on every single liquidity pool individually, or do the whole thing globally. And basically, like, usability for issuers won out over like simplicity of protocol design. And we ended up making it so that like basically you revoke and it just gets everything automatically. But both Cap 48 and Cap 49 just revert back to the, hey, you have to go and manually chase everything down mode, which is the only mode that is sensible in smart contract land. Like there's the only possible modes are you have to go and chase everything down yourself, or you can do nothing. But the third mode of it does it all automatically is not a feasible solution here. But basically the way that you would deal with this in the Cap, let's talk about the Cap 48 or Cap 49 world, doesn't really matter for the sake of argument. So let's just say in Cap 48, the way you would do this is like, hey, like suppose that I want to evade authorization stuff, and so I send my money to some random contract. Well, you look off chain and you say like, hey, like where has this guy been sending his money? Oh, he sent his money to this contract, freeze that address. And the issuer just goes through and kind of freezes everywhere where I'm sending money until they get all their money back. So basically, like your actions contaminate all the downstream systems. And that works fine because at the end of the day in Cap 48, all the money is stored, like when money is held by a contract, like Classic money is held by a contract, it's living in a trust line. And so you can just use the normal authorization techniques on it. Or in the Cap 49 world, there's like the interoperability layer has authorization, and you can do the exact same thing. You just do it at the contract layer instead of at the trust line layer. So you can do this. It's just kind of annoying.
Well, it's not
there's
just
nothing better you can do.
So the thing is that you can actually design better protocols that you want, like those smart contracts. If you want compliance, you should design a compliance protocol that actually allows to do something a little better than that. Because like this situation that you're describing here, I mean, it's like you're shutting down the bank because there's like one guy that, that doesn't behave, and that doesn't sound like practical.
I mean, I don't think you can do
like the smart contract is the bank, right? Like it's kind of like that. It's an automated thing that holds assets on behalf of a bunch of people.
I don't think you can generally do better than that. The reason being contracts are mutable. And so like, suppose that I have some contract and I claim to comply with your compliance protocol, right? Meaning like it's a contract that can hold asset A and asset B, and they claim to comply with both asset A's and asset B's compliance protocol. And then at some point they decide like, we don't want to do that. And they just redeploy without the compliance controls. And now that money is unrecoverable. So like the only thing, the only recourse the issuer would have against that would be to go and freeze up the bank anyway. So like, yes, you can design a protocol that has better properties than that. But the fact is that in a world with anything being mutable, you can't really, like, you can't avoid the need to fall back on that.
Of course, as a fallback, I see that is, you know, reasonable. But if that's the only option,
it's not the only option in a world with smart contracts, because you can design whatever you want.
Right, but like in the context of classic assets that are authorized, if we're saying that the default, this kind of default world that we are, that, you know, I had like a bunch of comments on like, are we forcing people to be opted into this new thing that doesn't fit the expectation from people?
I mean,
like, you know,
basically, like, if we don't opt people in, we'll end up in a world where everything is useless because people don't opt in. Like, in a world where we can't, like, where we can't assume that people will do anything, and that is the world we should assume we live in, then basically all the work we've been doing for the last 7 years could be a total waste. You know, like all the anchors we've onboarded and stuff, if we can't get them to take the actions that would be required, it's just like, hey, we just threw it all out. Ideally, everything just works automatically and we do the same thing. And if you want to do something better than the same thing, then that's when you have to take action. And that's the world I would expect. Like, for example, if you don't want this default behavior, hey, there's an easy solution to that. Set your asset to auth required, and then nobody will be able to send money into the smart contract side of it. And then all you have to do is just deploy your own wrapper and you get whatever functionality you want. But that's the action path. And since most people don't have auth required set, they don't have auth mutable set, they don't have auth revocable set, they don't have auth clawbackable or whatever the hell that one is called, clawback enabled or whatever, the default behavior is what everybody is inheriting anyway, all the time, right? Every day.
I'm talking about specifically, yeah, like for the mutable stuff, I agree. We can basically kind of take the same stance that I think we've been taking with claimable balances, for example, which is you take whatever the current statement of the issuer is kind of what you inherit, right?
No, that's not what I'm proposing at all.
You're muted, or I don't know.
Can you not hear me? I'm not muted on my side.
There was no sound.
I can hear.
I can hear him. He said that's not what he's proposing at all.
Okay, I don't know.
What I'm proposing is can you hear me now?
Yes, yeah.
Okay, what I'm proposing is that you inherit the current state of the flags, whatever they are.
Right, that's what I'm saying.
Yeah, like not like they don't get frozen. Like if I go and change my flags, I inherit the new flags. The way that it works for like author.
No, but like if you want to, yeah, but no, but like, well, if you wanted to, if you were saying, right now I'm not auth required, and then in future I become auth required, well, it's kind of too late. All this stuff is now out in smart and, you know, out of control, basically. Like, oh, well, you're kind of.
Yeah, and there's a great solution to that. You know what you do? You set yourself to auth required, and then you go and claw back everybody's money. That's it. Like,
would you really call that a great solution?
Yeah, it is a great solution, actually. The reason I consider it a great solution is because nobody has their flag set. So this can happen to you right now anyway, basically. Like, you know, like any issuer can come and just freeze up all your assets whenever they want to and just say like, hey, like you have two options. Either you are frozen forever or you accept my new terms of service and you basically do a swap. That's it. Anybody can do that at any time. And the thing I want to make happen is just have everything that works today just working smart. That is like my number one goal.
But the thing is, I mean, going back to this though, like I think it kind of breaks everything in smart if you allow people to just kind of, like I take the example of a pool, right? A trading pool. If I change the reserve in some random way, I'm breaking all the invariants of that pool.
Correct. And so there are two solutions to that problem, both of which I actually laid out in the email I sent to you. The first one is to say like, hey, like assets that aren't frozen as auth immutable, can't use them. Basically, like you check in advance whether it's good to go, and if it's not good to go, you can't do it. So in this case, it'd be like auth immutable, not auth revocable. The other option is you actually have a guard in your contract which checks that the balances are what you expect them to be. So basically, like you track the balances internally. There's only two in a liquidity pool, so it's not a big deal. And then when you actually start doing work, you check like, hey, like, are the balances on chain equal to the balances that I expect? If not, I know that there was an external thing, frozen. And that's basically like a single bad actor poisoning the bank. But in that world, there's a huge incentive for the owner of the contract to go and resolve the problem to liberate all their other users. So,
well, I don't know if they use a user for a contract.
what do you mean?
Like many of those, no, but like what I mean is that in many cases, the contract like is this thing that you want to lock, and that's kind of it. There is no like operator, right?
I mean, like if you want to live in a world where you're using auth required assets and you're taking multiple people's money, you better have an operator, because those problems can't always be resolved on chain. Like there's like the standard liquidity pool token would never, like design would never let you escape that situation.
But that's not the expectation in this Web3 world, is that you want to have like an AMM, right? Like you don't want to have like some random operator like controlling the internals of the AMM.
You might need to.
But
like if your contract is immutable and you accept the funds and the funds can be frozen, then there's just literally no way to resolve your problems without an operator. So the solution
so that's why like it sounds kind of broken to allow that to happen in the first place.
I don't think it's broken, and you should know better than to do that. Like the only other option is to prevent that and just say like, hey, like these assets are useless.
That's what I think we should do.
So you think that USDC should be useless?
It should be like if there is no yes, like no, like it's less like if it
okay, great.
Like,
so that's a huge point where we differ.
No, but like listen, like the choice here is either you allow people to clawback or like make random changes to your state, breaking all invariants. Like you can't write software. I mean, you have to know all those invariants ahead of time, right? Like what can happen? What are the situations that can happen with this one asset that I can accept? You have to kind of inherit that in every single smart contract. Because you have to make the assumption that, oh yeah, somebody can mess with my, trust lines or whatever, like, the equivalent of trust lines. That sounds kind of super weird.
So let me make a couple statements here. The first statement is like, you can write software that doesn't have this problem because you can have the guards on it. The second statement
but then everybody needs to put the guards.
Sure. The second statement is that on Ethereum, USDC is blacklistable. I've read the contract. It is very clearly blacklistable. In fact, I believe the term that they use in the contract actually is that it inherits blacklistable. So it's right there. And the third thing is there are liquidity pools that have that functionality nonetheless. That like, you can go and trade USDC in a liquidity pool.
So that's an extension to ERC20 then?
That is blacklistable?
Right.
Yeah, it's just additional functionality.
Right. But this is like, then it goes back to maybe like, we are not implementing ERC20 on the network. We're actually implementing something broader than that. We have to.
I don't agree. Like those contracts, the interface that like Uniswap is depending on is the ERC20 interface. The other stuff is just extension.
That's not true. You're saying that if what you do, you have an Uniswap pool with USDC, that can, like, I'm pretty sure, like you take, if what you're saying is true, if there's a pool somewhere on Ethereum, right, that has USDC, and USDC decides to blacklist the pool or do something crazy with it, the pool is now compromised. Basically, it's done.
That could be the case. We'd have to go and review the code, but that could be the case.
And then there's like potentially a cascading effect, right? Like, people may have this as collateral or something. Like it basically has all sorts of weird things.
Yeah, I think we'd have to go and confirm whether that's actually the case, but I do believe that is possible. But like the following statements are true. USDC is not auth immutable. USDC has no flags yet set. It is unlikely we will end up in a world where USDC will set any of the flags. especially immutable, because they'd like to control their future. And specifically, like, they won't set not revocable. And we know that because their Ethereum one is revocable. So like in this world, you basically you're saying like, if we don't want to handle that, then USDC should be useless on Smart. And then I would question whether we should do this at all.
I mean, I don't know, it sounds complicated to have like the default being like this super complex thing to deal with on Smart side. I mean, maybe, but that means that we have to expose more than just the ERC20.
We might be able to, I mean, one thing we might be able to do is make it so that assets are, like, we might be able to do the clawback inheritance thing, because it's a lot easier to deal with frozen than clawback. Frozen,
Yeah,
your contract
clawback
is fail.
Yeah, destroys everything. Yeah, it's too.
Well, it doesn't. Again, you can put the guards in, which do exactly the same thing. It's not hard. But
right, but it's still the same thing. Like you cannot use basically any assets, useful assets.
What do you mean? Sorry.
You're saying that USDC is not auth immutable. So
it is not. But if we did the clawback inheritance thing, it wouldn't really matter. You run a contract, you can check whether it has clawback enabled, and you don't have to do the clawback guards. And if you try to make a payment, you'll just fail because you're blacklisted.
Right. Yeah, I don't know.
Is there a next question we should move on to?
It's definitely no, like the thing that this conversation is really shows that it's going to be very hard for people to write smart contracts that don't break. Because if we are serious about compliance. And
if we don't add compliance into like the default thing that or like if we don't address this beyond what 48 currently defines, theoretically people are still going to want functionality probably like this for some assets, and so they're going to go and implement this themselves, I guess, in a contract. And then aren't we going to end up in the same situation? Like, people are going to write like a liquidity pool that doesn't handle those edge cases, just like what John, you were pointing out on happens on Ethereum.
But to be clear, I don't know that that's true for a fact, but I suspect it is.
Right. But I mean, like we're probably going to end up with something similar where we have the basic ERC20, somebody goes and defines a blacklistable or a deny listable interface. Some people ignore that, other people code around it. I don't know, it doesn't really sound like we're actually avoiding the problem by not implementing it in ours. We're saying like, we're not going to provide that interoperability if we don't.
I mean, I don't disagree with you, Lee. Like, if we don't provide this functionality and people require it, they will just build it.
Right. So by deciding to build it or not, we're not actually changing whether the problem exists or not. We're just saying that we're not going to support interoperability with these features of Stellar assets.
right. So I think what it comes down to, I think, is that it's like what I was saying, like what we need to then do is use classic assets as kind of the testing ground for what are those additional properties that you need to expose so that everybody from day one basically handles those edge cases.
there's like basically no chance we can achieve that. I want to emphasize, like,
no, but like it could be as simple as yeah, like exposing the auth flag or some, you know, something.
I mean, like my argument would be like, there's no way to globally handle clawback, at least. Like, the only thing you can do with clawback is check that you're not
clawback.
dead.
I'm not saying handle clawback. Like clawback, I think requires its own set of protocol, like actual APIs. You know, like when I say protocol here, I mean like, you know, what are like the methods that you need to expose as a smart contract in order to support kind of a nice low friction clawback. But I don't think that would be in scope in anytime soon. Like I think there is no, basically like we don't really support clawback in Smart. I mean, we don't support it as in, you know, if clawback is enabled, well, first you have to know about it. And then it potentially, if it can be enabled, you have to be able to handle the situations where it will happen.
Isn't that enough? Like, as long as a contract can detect whether the assets it is interacting with is clawback enabled, or if the contract's trust line is clawback enabled, not the asset, then the contract knows whether it can take on that risk or not, or whether it wants to interact. Because like we have the same problem with Starlight with the payment channels. Like payment channels don't work, or payment channels are not as safe if the assets can just be clawed back out of the payment channel. Like the payment, it's like undefined, you end up in an undefined behavior. And, you know, when we worked on that, we said, well, that's the risk you take if you do multi-asset channels. And if you do single asset channels, like you just need to work with the issuer. So are we saying this is a problem just because we expect people to write immutable contracts where there's no issue that you can go to? Like there's no one you can like talk to about the problem? Like, is that the distinction?
I mean, I think maybe like it would help to have like some concrete, super concrete examples on the cable. Because I mean, I think what's weird is that there's you know, even without clawback enabled, there's of course the ultimate clawback, which is that someone could say, we're not going to honor this asset and we're going to issue some new asset because something went horribly wrong, right? So you could always just make, the issuer can always make the token useless. So I think that we're worried about this, like this, I mean, it's not, maybe not improbable, but it's this kind of weird situation where someone kind of does something that is kind of changes the rules, but such that we don't believe that the asset is worthless anymore, but now we no longer know whom it belongs to. It's somehow like broken the attribution of who owns the asset, right? Like this is what we're worried about. Like if the asset were worthless, okay, fine, that was the risk we took. But if like that is still worth something, but maybe there's a contract with 2 units of A and 2 people who are allowed to claim it, and suddenly you've clawed back 1, and now the semantics is whoever gets there first gets to claim their A and the other person doesn't, and we think that's unfair. Or like, otherwise, could you just like paint some of these like scenarios that we're concerned about, like concretely what it might look like?
I mean, I think one concrete scenario would be like you have a liquidity pool that's pegged like that's between 2 USD like fully collateralized stablecoins. Call them USDT and USDC, and let's pretend, for the sake of argument, whether it's true or not, that USDT is in fact really actually truly collateralized. I'm not making a statement whether it is or isn't in this context. So let's pretend.
How about USDA and USDB?
Sure, great. USDA and USDB. And we'll just pretend we know which one's which. And basically, like you have this pool, and let's say it's got like 100 million USDA and 100 million USDB plus or minus epsilon on both sides, because maybe the price is actually like 99 cents or 99.9 cents or whatever, who cares? And then the issuer of USDB is like, oh, actually, that was like Osama bin Laden, my bad, and gets a call from the US government and like revokes $25 million. And now the pool, and sorry, I said revokes, I mean claws back $25 million. And now the pool is kind of in this like super borked state.
Well, Well, actually, what presumably would happen is immediately arbitrageurs would get in there and suck out a bunch of.
That's exactly what would happen. A
USDB,
whole
right?
bunch of money would be insta-destroyed, basically. Destroyed meaning sucked out to arbitrageurs. And that's kind of bad. Your only defense against this, or you could either say like, hey, like I checked that this asset was clawbackable and like that's a risk you took by putting money into this pool. Or you can say like, hey, like you can't make a pool if it's clawbackable. Or you can have a guard that checks whether the balances are still what the contract thought they were.
Can we step back from mechanism a second and say like, what is it? Suppose that like what we can do is between any two transactions, we can do whatever we want, right? So like, pretend we're God for a second and look, what does the ideal response to this look like? So first of all, it seems a little, is it the terrorists who've actually invested in the liquidity pool? So,
yes.
So it's like what you would really want to do is sort of like revoke the assets in proportion. You'd want to kind of like revoke the US government can only, let's say revoke USDA, not USDB. So what you should do is like, you should like freeze in proportion to what's been clawed back so that you keep the proportion of assets the same. Right. And ultimately the right thing to do is that the terrorists are not allowed to withdraw their money from the liquidity pool, and everybody else, it kind of is business as usual, right?
Right.
I think that's what you do in the current in our classic protocol today.
Yeah, exactly. We just want to replicate
withdraw, like we force to withdraw like the pool shares for that individual.
But I don't know if we want to replicate that behavior.
Okay, so can we first figure out what we would want in an ideal world, and then figure out whether there's sensible mechanisms that could achieve it?
Well, what's your definition of what you want?
That's what I'm trying to figure out. I mean, like,
No, I mean, like, what's even I guess maybe that's what you're asking. Like, what is even a desirable aspect of this?
Exactly.
Like, I guess let me describe to you what I would consider like the most ideal possible world.
Great.
The most ideal possible world would probably be that every contract, imagine you actually care about clawback. I don't know if we do, who cares, but let's pretend. So focusing on clawback, like the most ideal possible world would probably be that every contract implements a like issuer clawback function. And basically like the issuer is the only one who can call that, whatever you want the issuer to be. I'm talking about native, like classic assets. And the issuer's first point of call is to call that admin function when it wants to do something. And if it does that, the contract hopefully does the right thing. And if the contract doesn't provide that functionality or doesn't do the right thing, then the issuer just takes whatever action is necessary in order for them to comply, whatever that means, and damn all who suffer. That's probably like the best possible world you could achieve. So like, let's say that that's what we wanted to happen.
Okay.
So actually, before I continue, does anybody have a better world than that?
Okay, so basically we're adding a new method that like you're required to implement, or maybe there's a default value, but like the sensible way to implement it is that you do whatever should happen, but like basically your contract gets to react every time funds are clawed back.
No, that's not what I'm saying.
Oh, sorry, no.
I guess.
Where is this function defined? Is it defined on the contract that owns the asset, or is it defined on every contract that holds an asset?
I guess
defined on every contract.
It would be the whole. It has to be the contract that holds the asset. Like the pool has to implement that thing.
Yeah.
So the question is, we could do this, and so the question is like, is there a sensible default? Like, do we force everybody to implement this, or like? But then that's like a barrier to like deploying your smart contract, because now you have to like write more code. Or is there some kind of default? Like the default is like the contract is frozen until it gets upgraded or something, or I don't know. Like,
I think the default should be you can opt out basically of this whole thing. Like you can basically say, I don't want to deal with assets that have those type of properties. Because it's,
Oh, I see. So if you haven't implemented this function, then you just can't hold certain assets that are.
No, I totally don't think this makes any sense.
Right.
Because I can implement this function and just assert. That could be my whole implementation.
Well, that's what I mean. So assert basically says freeze the smart contract until as soon as any funds have been clawed back from it.
And sorry, I cut off late.
Yeah,
Because
so
it's release contract. Yeah. I guess no. Like I think David is probably right. You don't want to. You don't want to kind of have like in the case of a pool, right? You probably don't want to have like an arbitrary amount taken under your feet, because this breaks all your invariants. Instead, you want to just you want that to happen, and probably in addition, the contract gets completely stopped. The default, I'm talking about the default.
Yeah, so the default is that it should stop the contract, but also it should grant someone permission to upgrade the contract or something, right? I mean, that's... I mean, like, basically what we need is like human intervention, right? Like, we did this thing assuming that these dollars were fine, and suddenly like the rules have completely changed. So of course we could just lock all the assets in perpetuity, or we could like, figure out some way to like, arbitrate the situation, which might require human judgment, because this wasn't something we anticipated.
We put like a 20 digits proof of work, unlock code on it.
So I want to go back to something that you said, David, like what, if you don't define this function, then, you don't support these type of assets. I think like we're talking about two different things here. Like there's contract deciding if they want to use an asset, and they could do that if we provide a way for them just to read their own trust line. Like, does my trust line have clawback enabled? Simple function, simple flag.
No, but I'm saying like if a contract has any trust line that gets clawed back, then there has to be then there's a function to kind of deal with that. There's like a call.
Yes. So I think what we're talking about is hooks, or the idea of to hook into an event that's happening, rather than having a function that does the thing that needs to happen. We just want like a function that notifies the contract this is happening, whether you like it or not, because you decided to hold a clawbackable asset. So exactly. Like once you hold it, you can't get out of this happening, and then you just get told when it happens. So contracts don't have to provide that function if they don't care that it happens. It'll just happen, and the consequences will just be whatever they are. But if you care about it and you want to mutate your internal state maybe, or update something, then you have the option to do that.
But I guess what we're anticipating is that there are a bunch of situations where people write contracts without any possible idea, like they just can't imagine that USDC would ever like try to claw back their asset. And yet, 2 years later, USDC like sets the clawbackable, whatever it's called, clawback enabled flag on their account, and actually like claws something back, right? And so basically,
you can't do that though. Like, so clawback is designed so that once you have a trust line, you can't get enabled. So I mean, we've already designed around that. And I think the other thing we can do is, we can make the SDK or however you're writing contracts, so that when the contract says I'm willing to hold an asset, I'm assuming that we're going to have some way of saying that, like on Stellar, like on Classic. You have to explicitly say that you're going to allow the asset to be clawbackable. And then, maybe that call fails if you just haven't passed that flag in, if the asset is clawbackable. Like, that's a good way to protect against it.
So then coming back, I think, John, like your example then is not so scary, because in your example, either USDA or USDB already had to be have clawback enabled, right? So is there some other example that's more scary?
So actually, just to be clear, in the proposal I wrote, it was actually based off of the current flag. So like things could become clawbackable later. We don't have to do it like that.
But they can't become clawbackable later for an existing trust line.
Well, that's how like the current stuff works. That's not what my proposal specified. At least not Cap 49. Cap 48, I guess, does work like that kind of default. It doesn't have to be like that. We could make it all work like this. Just a little extra complexity to deal with some stuff, but it might save complexity somewhere else. But the thing that I'm like skeptical about here is like the notion of a callback here. Like, you probably don't want to do callbacks.
Callback, it could be that like the contract is stuck until someone calls the cleanup clawback method or something. But
my argument would really be like, to implement this the whole opposite way, which is basically like, hey, like we have a strong recommendation for you to implement this function. And if you implement it, we encourage issuers to use it. There's no promise that they will. Because at the end of the day, like if the issuer needs to do something unilaterally, they should be able to. And since
Sure, but hold on. Why should this be up to the issuers? Like I guess what I'm saying is like the invocation should be a result of something happening on Classic, not of the issuer doing some kind of smart contracty thing.
No, it definitely has to be a smart contracty thing, first of all.
Because
no, definitely
should not be, the issuer should not be paying gas to clean up other people's smart contracts who did not like anticipate something being.
Well, that raises a problem then, because like if I write my hook, my callback to use like some obscene amount of gas, like who's going to pay for that?
Well, that's the point. Like somebody who cares about that contract.
What? No. Oh, well, you're saying if it's called at a different time.
I'm saying
like, I mean, at the end of the day, like the callback could always fail, right? Even if you implement it and you think it won't fail, it could still, like, for example, like consider like a USDI, USDB liquidity pool, right? What does a clawback on Stellar do? Well, it returns both assets. Well, what if the other asset you were already frozen? Well, then the operation would fail. And so like at the end of the day, like there has to be the support for a unilateral clawback anyway, and the contract has to handle that. And so like in the world where there is a unilateral clawback, we might as well just say that the contract should supply a function and the issuer should call it, but you have to deal with it if they don't anyway.
So if anybody can call this function, is that like, can anybody call the function? Or
I would say that it should have a guard on the issuer type of thing. So basically it should check like, hey, like is the person who can call this the person who can call it?
I mean, presumably what it should do, like the function should like examine all the trust lines, and if they're all in the expected state, not do anything, and otherwise clean up the mess.
Yeah, I feel like what we're describing is like some general function, like we're actually describing a more general function that just is something might be wrong, go check your state.
Yeah.
Figure it out if it's not. And like, we're not actually talking about clawback specifically. We're more talking about how to get a contract unstuck that gets in a bad state.
That's not really what I'm talking about.
Yeah, that's way harder to try.
Like, there's only one, if you're in a generically borked state, there's only one solution: human intervention. That's the only possible solution if you're generically borked. Because in what way are you borked? Well, only a human can determine that unless you've written a program that can analyze the state of all the possible states that you're in. And since like that sounds generally hard and like generally not feasible in a gas like resource constrained world, there's like no hope of that. So
okay, so the distinction of the function you're talking about is that because only the issuer could call this, because there's a guard for that, me writing a contract, I can trust the issuer will only call this if they are in fact doing this thing.
I'm very clearly saying like there's no protocol specifications here at all. The only thing I'm saying is like it is a recommendation to people who write contracts that they should provide a function that implements clawback if they would like to hold clawbackable assets.
Right, but as the contract author, I need to be thinking about where my trust lies. So if this function is going to mutate the internal state of my contract, I've got to be trusting the issuer to only call it when this is actually happening.
I don't necessarily know what you mean. Like the function should be implemented in such a way that it leaves your contract in a sane state. So like if you want it to only be callable by the issuer, which would be the same thing to do, you should check that. But you don't have to check that. In theory, you could let anybody claw back on your contract. It just sucks.
You do not want to be called by the issuer, right? The issuer is not in general going to know about every smart contract using their asset. Well, you want to be callable by anyone, but only do anything if like something unexpected is happening in the state of your trust lines, right? So you want like basically a board on borked check that's at the beginning of most of your methods, right? And then you want a clean up the mess method that like anybody can call to like clean up the thing that's causing all the other methods to
I think John's function the issuer is clawing back from the contracts account. And so the issuer knows about the contract in this case because they're clawing it back. So that's why they know to call that function on the contract.
And if
I mean,
the
I'm
account has already had
thinking-
its funds clawed back, then clearly
why
the
do they
issuer
care?
knew
Like,
about
let's
it.
not like maybe the issuer only does classic, like does USDC care about smart contracts? Like, they're there to provide an asset that has a well-defined, redemption path, and like that's fine. They're not here to like parse people's smart contracts and spend a bunch of gas doing whatever, right? So I feel like what we need to do is just have a way for people who care about a smart contract to clean up the mess when the smart contract's assumptions about assets are no longer correct, or about trust lines.
Which in theory, we've been talking about mutable contracts. So like, even if a contract is in the worst possible state, somebody can upload a new version of that contract to fix it.
Only if somebody can actually do so. Right. But like Nico protested against my notion that these contracts would even be mutable. If they're mutable, there's no problem here. Like, in the world where the contracts are mutable and somebody actually has the authority to mutate them, whether that is like an issue, like not an issue, sorry, an organization, an entity, or a person, there's no problem. The accounts get frozen or the account gets clawed back. The issuer just, the owner of that contract just calls up the issuer of the asset and says like, hey, like, how do we fix this problem? Oh, this is how we need to mutate the state. Cool, I'll write the function to do that.
I mean, one can imagine, wanting to set up a contract that you can only change when it gets borked or something. Like, maybe there's value for like, yes, if suddenly like USDC gets clawed back, then I get the ability to upgrade this contract. But usually I don't want this ability because like, the contract should be its own logic.
That would be easy to write though. You could write that contract. That's not hard. You can do that without any magic at all. So I don't know. I feel like we're not all talking about the same thing here. And I think that's why we're not agreeing on stuff. Like,
outside of clawbacks, are there other like types of edge cases that this would apply to? Or is it just the classic clawbacks, a clawback enabled asset that gets that invokes clawback, classic clawback, right? Are there other state changes that could happen on classic that would lead to this situation, or is this limited to clawbacks?
I mean, like, getting frozen would be not as complicated, but equally bad.
So an auth required token where you deauthorize the trust line. So there are the other auth flags because it's also like, can we just say, hey, no clawback enabled assets in smart contracts, can't use them?
Maybe. Like, maybe. I mean, like, here's a way that you could implement this if we wanted that. Basically, like, you can only create in the Cat 48 world, you can only create a trust line for a smart contract to an asset that is already going. Basically, like, that operation of creating the trust line would fail if you would end up with the clawback enabled flag on your trust line. And then you just never end up in this world.
Yeah, I think we should just make it like a choice. You call trust line with no options, and that's the case. It just fails if it's callback enabled. Or there's like an additional flag or option you can pass that just says like, I'm willing to go the potentially unsafe route of having a trust line that's callback enabled. And then at least it's surfaced to the developer, like it's in their face. It's the same thing that we were talking about with reentry.
Yeah.
Just surface it so they know about it.
David, on the context of the cleanup method, I think the big issue with the cleanup method is like, there are worlds that you can enter where you don't know how to clean up. Like, you don't necessarily know like, suppose that an issuer claws back from your contract. Do you know why they did that? So how do you fix the state of your contract?
Well, I'm thinking like what the cleanup method could do is it could like add a signing key to, or it could somehow like enable the author of the contract to upgrade it, for example, or
like it goes in safe mode or something, and then it unlocks some like a maintenance. I think that's one of the like patterns that some smart contracts have already. Like you have like even the ones that have like a DAO, like you have, you can basically go into this maintenance mode. It just takes like a week or something. Like it's not instant. There was a bug a few months ago actually on I think a bridge protocol or something where it was not a week, it was like a second instead. But yeah.
I don't know. Personally, I just feel like we're making this really complicated. Like
Yeah.
at the end of the day, I feel like usability should be front of mind for developers. And like if we make this complicated, nobody's going to use it, and then we failed.
Right. So can I say something?
But the question is, so the point, but so we would need to have a default for this method, right? So like we're not saying like everybody has to implement a method, but like basically the problem is that like people are going to make assumptions about trust lines, and every once in a while these assumptions may like break like a way that's would cause like really weird like unspecified behavior of the smart contract. And so should we have some default thing where like by default the contract like enters maintenance mode or whatever when these assumptions are broken?
I mean, that assumes that we impose a maintenance mode onto the entire world, and I just don't think we should. Like if you want that behavior.
Well, you said assert. What happens when an assert fails? Like are you seriously thinking about having an assert?
Well, what I meant about an assert was like I was actually giving you a pathological case of where what you were proposing wouldn't work, where the cleanup method it just asserts and fails. It just does nothing. You cannot do it. It's like, well, what good did that do you, right? Like anybody could provide that.
And also for an assert to have an assert, you also need to write that condition in the first place, right? Like
no, I'm saying just like assert false. That's
no. I see. Yeah. No, but I was even thinking for like. Even if you have like all the defaults and all that stuff, like you have to write your invariants in a way so that you can know basically that you are balked. And that sounds kind of not workable.
Well, I mean, I guess, my proposal would basically be that anytime a third party like forcibly does something to one of your trust lines, you get in a state where someone has to call this cleanup function. If you haven't implemented the cleanup function, then like nothing can happen to your contract.
That just sounds undesirable to me. Like, but maybe your contract doesn't fit.
Sounds pretty undesirable too, which is that like whoever first which is like a bunch of arbitrageurs go in and suck out like all the money that's there by accident.
No, my proposal is just that like if you're a contract developer, you should handle it. Figure out what you're supposed to do.
You can. But how do we know people are going to do this, right?
We don't. And if they don't, then like it's the same thing as any other smart contract.
So when they don't, do we want like people to lose money to arbitrageurs, or do we want like the contract to freeze and people have to like debate how to clean up the mess?
What if it can't be cleaned up? Like what if there's nobody who owns the contract? That was the case that Nico was talking about. If nobody owns the contract, nobody can clean it up, and now the money's just locked up forever.
Well, then maybe the default implementation of this function is that it like hands signing authority back to whichever account like created the smart contract.
What if they don't have the key anymore?
Yeah, then everybody loses their money.
Well, that's the world that Nico was talking about with the contract being immutable. Like again, if the contract is mutable, there's just not really a problem here.
Well, it is a problem if everybody loses their money.
No, in the world where the contracts are mutable and people can actually perform the mutation, I mean, there's not really a problem because people can just come through and clean up the mess.
Right. No, sorry, they can't clean up the mess if arbitrageurs have sucked out a bunch of money.
So that's why you should handle the guarding conditions that you need if you do need them.
Well, I feel like we're out of time for this discussion right here in person today, but it seems like there's a lot. I mean, I think we just got to keep working async on the dev discussion mailing list and on the Discord and reconvene here next week. I don't know what the next steps are though.
I mean, like the thing I wanted to say is like, I think for the first phase of this, I think I would do what Lee was saying, which is like, we don't support global assets, right? Like if you have to have on your trust line, basically, this for those classic things I'm talking about. for that first version. You can't do anything, right? And then you can deploy a contract basically that uses that. And then in parallel or later, we can figure out this global, like how can we make clawback work in smart world, and then retrofit this to classic.
I think the main lines of work should be, the first one should be like, let's go and figure out what happens with these kinds of contracts on Ethereum. Like, these problems exist. People are doing something. Let's find out what they're doing.
They don't though, right? Because the one thing that's different here is that there's the classic world is going to kind of reach in and mess with the smart contract world in a way that can't happen in Ethereum.
That's not true. Like, I literally told you that USDC has an auth revoke function.
It has revoke, like, so it has, yeah, you can revoke. I don't know if they have, do they have a clawback?
I don't think so.
Because that would be, that's the one that really breaks everything.
I mean, they both break everything, but clawback is
but like
harder to deal
breaks
with.
something more.
See you next week.
Bye, David.
I see you next week.
We should go and figure out what people are doing,
yeah,
and how they're handling it, and then we should resume this. But again, like, I'm strongly in favor of keeping it simple.
I know that there's like the theoretical possibilities in edge cases, but I think it's also worth pointing out that I don't know that there are any active clawback enabled assets in Classic right now. Just FYI.
I agree with that.
Yeah. All right. See everybody next week. Thanks.